today is the brief introduction to the Seaborn statistical plotting library. This is really handy because it meshes with pandas almost seamlessly. The data functions or the data structures from pandas slot right into Seaborn functions. They were meant to work together. And it's also built entirely with matplotlib. So Seaborn lets you design and quickly output presentation-ready statistical plots from pandas data structures. There's a wide variety of statistical plots that you can produce with pandas, but we'll focus on just a couple that are especially hard to replicate with matplotlib. And we'll use a couple of Seaborn's built-in test data sets, of which there are several, and these are really handy also to play with pandas with. One thing I should caution you about is that Seaborn does have a built-in regression function to be used on to do linear regression on pair plots, but we won't cover it because Seaborn does not return any of the parameters needed to assess the quality of the fit, and the official documentation itself warns that you shouldn't use that. It's just there to motivate more in-depth analysis. So for most HPC centers, if there is an interactive interface that's available, it's recommended that you use it because you're going to be doing a lot of tuning and playing around with visuals before you get around to automating the output. Now, I mean, once you have automated the output, then of course you can always run these programs from the command line or from a batch script. But while you're playing around with the data and trying to polish it, it's recommended that you work with something like Spider or Jupyter. So on both LUNARC and HPC2N, the interactive use is recommended. So on HPC2N, you would go to the interactive open on-demand web portal, start a Jupyter notebook or VS Code if it's got a Jupyter Lab extension, as described here in the Kebnekaise documentation, and as described on day 2 in the on-demand lecture session. Spider is not even available anymore, I don't think. Actually, last time I looked, it was not available. So if you want to use Seaborn in a batch script, all you have to do is load the compiler and then Seaborn. And these Seaborn modules will pull in matplotlib, tkinter, and scipy bundle internally. So you don't have to remember all of those. It just pulls all of those as dependencies. Similarly, on Cosmos, the recommended use is that you start a ThinLink session and open one of Spider, Jupyter Lab, or VS Code. Both Spider and Jupyter Lab are configured to load Seaborn and all its dependencies automatically via the latest version of Anaconda. VS Code requires modules to be selected to load as part of the additional job settings. If you want to use it in a batch script, again, all you have to load is the compiler in Seaborn, and it will pull in all of its dependencies on the fly. And that's if you prefer pip install packages. If you want to use Anaconda, you can just load whichever Anaconda version you want. This is the recommended version. Earlier versions of Anaconda use a version of Seaborn. I believe it goes between 2022 and this 2024 Anaconda version. There is a version of Seaborn that has a very small bug in the heat map function. But if you're not using that, then any of the Anacondas will do. If you're on Pele, all you have to load is Seaborn. 0.13.2-GFBF-2024A. This can be loaded directly, and it pulls in the scipy bundle and matplotlib, but it does not add any IDEs, so you would have to load those separately. So like Jupyter Lab you would have to start in a like an interactive session. In a ThinLink session, you would start interactive -A project name, give the time as discussed in the interactive usage lesson, and then load this Seaborn, and then load and run your preferred IDE. This is what you would use in a batch script. On Tetralith, for this session, you should load all of these modules and the Jupyter bundle, which I believe was supposed to be in this one, not in the previous one. So you'll have to load the build tool, the compiler, Python, and SciPy bundle. And unlike some of these other ones, you do actually have to install pip. You have to pip install Seaborn locally. For interactive use, now this is all for use at the command line or in a shell script. If you want to use it in interactive mode, you follow the interactive usage on lesson from day 2. Load the Jupyter Lab module as it appears here, or swap out Jupyter Lab for your preferred IDE. And if you've already installed Seaborn, then that should be in your home directory, which is always in path. So you shouldn't have to load anything additional except for the IDE. Again, you have to be wary of the lack of ThinLink licenses on Dardal. So if you want to run Seaborn from the command line, having already, for instance, done the testing on your own computer, then what you would need to load is Cray Python, then PDC old 23.12, then Matplotlib. And unlike all the other facilities, Seaborn is actually included in the Matplotlib module on Dardal. If you're lucky enough to get interactive use on ThinLink, then these are the instructions that you would follow. I'm not going to go into them because I do not trust that anybody's actually going to access those. And then for Alvis, it's the same as all the previous sessions. You log into the Alvis portal. You request a terminal on the back end, and then you load the Seaborn module, which pulls in all of the other dependencies like Matplotlib and SciPy bundle on the fly. And then if you want to use Jupyter as your IDE, then you load the Jupyter bundle as well. And then you can start Jupyter Lab with this. So Alvis and Pele are kind of set up similar, and Kebnekaise and Cosmos are set up similar. And then Dardal is its own thing, and Tetralith is kind of its own thing. In all cases, once you've loaded Seaborn, it can be imported directly in Python, and the typical abbreviation that you'll see in documentation is SNS. And both Seaborn, the name Seaborn and the abbreviation SNS are both from the West Wing. If you've never seen the West Wing, like I haven't, any sensible abbreviation will do. I use SB, just because it's easier for me to remember. Again, you do want to check and make sure when you've loaded your modules that some version of tk-enter is loaded. And if you're going to be running any code from the command line or from a batch script, and if you want that batch script to output something that pops up in a GUI for you, then you need to use this matplotlib.use tk-enter. And if you run code snippets in Jupyter, you'll need to make sure you include this matplotlib inline. That should be 1% and no space. Stuff like that. So let's go over briefly some common features in Seaborn. So one of the most convenient things is that it has sample data sets. Now, most of these are kind of old and they're not very big, but they are big enough to demonstrate the functionality of pandas and the functionality of Seaborn. So you can, from the name of the module, whether you call that SB or SNS, you call .load datasets, and then as the argument, you supply maybe one of these. And you can get the full list of datasets by calling .get dataset names. This requires the internet. Or you can visit this GitHub repository and follow the links under the README. So these give you all sorts of little subsets of the data. And I put in a pull request recently to change the exoplanets data set to what was essentially the exoplanets data set that I showed you with pandas. Because the current planets data set is a much older sample. It's only like 700 rows as opposed to 5,000. And it doesn't have as many of the physical and orbital parameters. So hopefully that'll be updated soon. But it's been waiting a while, so. For most of this tutorial, we'll be using the MPG data sets. And for one of the exercises, I'll have you use the penguins data set. When you're doing plotting functions, since Seaborn is designed to take pandas data frames, or sometimes series, as inputs, different plot types share many of the same quarks. And Seaborn does not actually have any mandatory positional args, although you can, there is one mandatory argument for each one, and that is that it's the actual data frame itself. However, you can supply it as an arg or a quark. But typically what you do is you supply the data frame, and then you supply the X and Y, the names of the two columns in your data frames that you want to plot against each other. Unless you're using something like heat map or pair plot, where you're plotting every possible combination, and then you don't have to give those. Then there's this convenient hue quark, which accepts a categorical variable like species or sex or brand as a column name, and then it groups the data by those categories and plots them all in the same plot in a different color. So that's really nice. And then there's this ax quark, which you often don't need. And that takes the name of an axis object should you want to add your Seaborn plot as a subplot of an existing figure. Generally, this is only possible for figures that do pairwise plots. A couple of the plots that I'm actually showing with Seaborn are the types of plots that take up entire figures. So you won't actually use the ax quark, but it would be something for like a violin plot, which is very much easier to produce with Seaborn than it is with Matplotlib. So the Seaborn plotting commands look almost identical, whether you use the implicit or explicit interface apart from the X quark, which is only required if you want to add a Seaborn subplot to another figure. But you do lose a little bit of the automatic features like exterior legends with Seaborn. Without the X quark, a Seaborn plot will occupy the entire figure. And in those types of formats, the formatting the axes can be a bit trickier. And the reason why formatting the axes can be trickier is that Seaborn typically titles the axes by the names as they appear in the data frame in the column names, underscores, lack of capitalization, all of that stuff, missing units. It's easy enough to override the labels for a simple pairwise plot, but it can be a bit tricky when you're trying to typeset something like a pair plot or a corner plot where you've got multiple rows and multiple columns of subfigures. But I do include a demo just so you know one way that you can fix it. There are a lot of these functions have a lot of these Seaborn functions are have a high level version and then a more flexible base class method that lets you layer different types of plots on top of each other. But almost everything in Seaborn is tunable. So if you find that whichever type of plot doesn't offer the customization that you want, check the documentation. There's probably a base class that will let you do more with that figure. So regarding showing and saving figures, the easiest way to do this is just to import matplotlib.pyplot as plot and use the standard plot.show and plot.savefig commands. You'll avoid a lot of trouble this way. However, it is possible to get this functionality with Seaborn using this .figure accessor, although this is a lot easier for saving your figure than it is for showing your figure. With saving your figure, all you have to do is call .figure.savefig and then give the name of the file. And then that takes all the same quargs as pyplot's savefig function, because it's just a wrapper for that function. And the only reason you use this is so you don't have to import matplotlib. Showing your figure, on the other hand, in an IDE, this is trivial. You just assign your plotting command to a variable and call .figure.show. But in a script from the command line, you may as well use plot.show because the things that you have to use to work around the peculiarities of figure.show are annoying. Unlike plot.show, this Seaborn.figure.show function does not, for whatever reason, keep the graphic open. Like it'll close almost immediately as soon as it appears when you run the function. Whereas plot.show keeps the script from terminating until the user closes the graphic. I don't know why they haven't fixed this, but they haven't. So the way that you have to do this, the way that you have to fix this is that after the line containing .figure.show, you can add an input command like press any key to exit, and that will hold the script open until you exit with it at the press of a key. Alternatively, you can run the script with this .interactive I flag between Python and the name of the script. However, what this does is that once you close the figure, you will have stepped into a Python shell, which is fine. It's not a huge deal. You just Control D to exit, but you might not want to do that if you're in the middle of something else. So we're running low on time, so I will try to keep this relatively quick. A couple of the types of plots that Seaborn offers that are very difficult to replicate in matplotlib are there's a pair plot and the underlying pair grid function. You might know this better as corner plot. However, the corner plot option kind of has to be tweaked manually so that it doesn't mirror the lower off diagonals to the upper off diagonals. There's joint plot, which is kind of a special case of pair plot for only two variables. And then there's heat map and cluster map, which are for showing basically individual, well, I'll show you in a second. So when you're first starting analysis, one of the things that you often have to do is view bivariate distributions of many combinations of numeric variables. For a typical data set and typical display settings, it's usually enough to use Seaborn's pair plot function, which wraps pair grid underneath. Any categorical data column not specified by hue is ignored automatically. So you don't have to worry about setting like numeric only equals true like you have to do with some of the Panda statistics functions, for instance. So for a demo, I have this miles per gallon data set, and I show some of the statistics or some of the details about what's in here, just so you can see what's in there. If there are more than about 5 or 6 numeric variables, a pair plot featuring all of them can become really hard to read if you're constrained to the size of a journal page. So just keep that in mind and plot only what's necessary. So here in this miles per gallon data set, you have you have a bunch of stats for about 400 different cars of different makes and models. Gives the name of the car, the origin, model year, acceleration from like, I think 0 to 60 miles an hour, the weight, the horsepower. I don't actually know what displacement is. I'm not a car person. Then the cylinders, number of cylinders in the engine, and then the miles per gallon. So for the following plot, I've dropped cylinders, model year, and name, and I kept the country of origin for the hue. So here's what the plot looks like when we plot fuel economy or miles per gallon against displacement, horsepower, weight, and acceleration. So this is a very lovely type of plot. Like the first time I saw a plot that looked like this, it was just a thing of beauty to me. And 99% of that plot is just these two lines here. I've loaded the data set. I've dropped a few of the columns that I didn't want to bother plotting. And then the whole plotting function is just this. Everything after this is what was necessary to format the X and Y axes labels as you would want them to appear in a publication, as opposed to the way they appear in the data set, so like if you were to actually put model year on that plot, it would appear as all lowercase and with that underscore, which is not what you want on an actual publication ready plot. So the plot itself is just this one line. Everything else is just fixing the labels. So by default, the off diagonals are scatter plots, and the marginal distributions, are, let me close that and close this. So by default, the off diagonals are scatter plots, and the marginal distributions on the diagonal are either histograms if the data are not shaded by a categorical variable, so there's only one, or they're kernel density functions if the hue quark is used. And basically these kernel density estimations are sort of like smooth histograms that are smooth by convolution with a Gaussian kernel. And this just makes them easier to read when they're stacked on top of each other, because they're smooth and then they can be shaded continuously. These options can be modified without resorting to pair grid, but with pair grid, you can do a lot more customization as far as maybe you want to show a scatter plots on the lower off diagonals and two-dimensional KDEs on the upper off diagonals. Well, you can do that with pair grid. Whereas with pair plot, all I did here was just set corner equals true just to turn the upper off diagonals off. So as an exercise, you want to load the penguins data set and make a pair plot where the data are colored by species. And you don't need to format the axis labels. And I didn't really include the solution because this is actually exactly what's in the demonstration of the Seaborn pair plot documentation. So if you were to do this on your own, as an exercise, if you wanted to do this on your own, this is what you should get as a result. If you set hue equals, no, if you set hue equals species, you get this. So in the interest of time, I will go ahead and move on. But I encourage you to do the exercise in your when you get a chance, just for practice. A special case of this is joint plots, and here you actually do have to give an X and Y. So here I've given weight in miles per gallon, but everything else about this is the same as pair plot. So here you just get, so here it's just a single pairwise distribution, and then you get the marginal distributions of each variable as these little histograms on the sides. The only other plot I'd like to show you before we go to break, or before we break for lunch, is heat map and cluster map. Sometimes you have either too many variables to look at with pair plots or corner plots, and the best thing you can do is plot correlation coefficients between different parameters, or you might have a data frame that has a comparable number of numeric rows and columns, and or like the data is more like a two-dimensional histogram. And then you want to see how the rows and columns correlate. Either way, the data frame that you want to would have to be must be able to be the data frame must be able to be coerced to ND array. But if you have that type of data structure, this type of plot is super tedious in Matplotlib, but extremely easy in Seaborn. There's two functions that do this. There's Seaborn.heatmap and Seaborn.clustermap. The main difference is just that clustermap attempts to rearrange the variables so that these are correlated, and the ones that are correlated are positioned next to each other and connected by a tree diagram. So here's an example. And the last exercise prompt is just to take this code and modify it so that it produces a cluster map. So I am going to just straight up copy this, and I'm going to very briefly restart Jupyter just so you can see what this does. Python, Lab. And I'm going to just take the default settings except for the project, because I don't need anything much. And then once this loads, I'm going to go down to this empty slot here. And first, I'm just going to show you what this is supposed to plot when it's so with heat map, what I've done is I've just computed the correlation of all of the numeric columns in the miles per gallon data frame. And maybe this probably wasn't the smartest thing to do with model year, but that's okay. It's or model weight or cylinders, because they're kind of discrete, but it still technically works. So. And then this NO equals true, that quarg is just what makes sure all of these numbers show up. Format is what controls the format of these numbers so that they don't get too big. And then for color bar quargs, I've just set the label to correlation coefficients. So this just tells the C bar quargs is just where you, this is how you title the color bar axis. Now let me show you what cluster map does. I can just do cluster map. Now you can see this does a much bigger plot because it's grouping all of these and trying to plot this little tree diagram to show which parameters are correlated. So that's what I was hoping you would have time to do as an exercise for yourself, but you could have coded along with me or try to run it yourself with a maybe you can run this yourself in your free time with the pandas or the penguins data set and see how that looks. That's just a post option. There is one thing I want to note, and that is before we go, and that is that there is a bug in Seaborn version 0.12.2, 0.12.2, and that causes heat map and cluster map to, with anode equals true, to only label this top row. It's fixed in a later version. So before we go to break, Seaborn makes statistical plots easy and good looking. They take Seaborn plotting functions takes pandas data frame as is, or sometimes the names of the individual columns, and often a hue quark that makes different subsets of the data appear in different colors, depending on the categorical variable. Seaborn also offers data sets to play with. So wonderful for making plots. It's only really painful if you have to typeset the axes properly for publication. And saving and showing the figures are best done with the standard pyplot functions. So if you want to know how to run Seaborn functions from the command line or from a batch script, it's apart from loading the Seaborn functions and using the Seaborn calling functions, the methods are similar to what you use for standard matplotlib. All right, any questions before we go to the break?